Hello, in this video we want to begin looking at Chapter 10 of Brown, LeMay, Bursten, and Murphy's Chemistry, the Central Science. This chapter is on gases. And so this is a quick introduction to gases, some of the basics in the very first section of the chapter. Stuff that's fairly common sense, I think, things you probably already know, but hey, we're introducing gases, so let's do it. Let's do the basics. Gases, the basics. Okay, so one thing about gases is they can have quite different chemical properties, but their physical properties are quite similar. Now, you might remember way back in Chapter 1 of chemistry that chemical properties have to do with the interactions of substances. So, you know, if you take sodium and you throw it into a river, oh, that I could do it, by the way, wear gloves. But I long one day to do this, to take a big chunk of sodium and just haul it into a river and watch it go boom, you know, when it hits the surface. Now, I've not had the chance to do that yet. But that's a chemical reaction. And the substances of sodium and H2O are interacting quite violently. But physical properties don't have to do with the way things interact, but with the way things are. This has to do with for example, what happens to them as their temperature, you know, they expand, they contract. It's blue. You know, physical properties are a little bit different from chemical properties. The physical properties of gases tend to be quite similar. Gases behave in very similar or follow very similar patterns in the way that they are. Okay. Physical properties. Okay, so air is a mixture of gases, primarily nitrogen. Now, of course, oxygen is of great interest to us. We all know that if you don't have oxygen, you can't live. We need oxygen to breathe. Although oxygen only makes up about 21% of the air around us. The primary ingredient of the air around us is nitrogen, and it's 78% of the air around us is nitrogen. And then, well, you add those together and you've got, what, 99? Wow. And so there are only really trace elements of other gases in the atmosphere. The atmosphere is overwhelmingly nitrogen and oxygen. So only a few of the elements are gases at room temperature. So, for example, if you want to make, I don't know, if you want to take, let me come up with something. Mercury. If you want to make mercury into a gas, you're going to have to really heat it up because it's liquid. But basically, very, very few elements are gases at the normal kind of temperature that humans find comfortable. Noble gases, these are the column 8 gases, group 8, things like helium, neon, argon, krypton. These noble gases are monotonic. So if you have a balloon full of helium, the molecules are just not molecules. They're just helium atoms floating around there. There are a few diatomic gases at room temperature. So hydrogen, nitrogen, oxygen, fluorine, and chlorine. These are at room temperature diatomic gas molecules. You'll notice that there aren't any there are no metallic gases here. And most of them are simple. When we talk about water being in its gas form, we call it a vapor. But the kind of more simple hydrogen, oxygen gases they're not metals, and they are fairly simple and low on the periodic table in terms of the numbers. Okay, so these are some of the basic things in the first section of this chapter on gases. There are just a few more. Gases fill, so again, we're talking about the physical properties being the same. Well, gases will expand to fill a container. All gases do this. And so if I throw some hydrogen atoms into the air, they're going to disperse on average equally in whatever space you put them in. Gases are going to expand to fill a container. And this physical property is going to be true of all gases. Gases are highly compressible. So I can take the air in this room, and if I were to, if this were a room in which the walls began to, I'm in a Indiana Jones movie, and the walls begin to compress, the air is going to fairly easily compress into that space. So gases are highly compressible as opposed to, say, liquids or solids. Liquids and solids are going to take a lot more force to compress them than it will take to compress a gas. Gases form homogeneous mixtures with other gases. So if I take a little bit of oxygen, a little nitrogen, a little helium, they're all going to mix evenly distributed, on average, in the room. That's a homogeneous mixture. Not liquids don't always do that, oil and water and so forth. And of course, you can have a branch, which is a whole bunch of different unevenly distributed stuff. But gases are going to distribute homogeneously in mixture. So air is a homogeneous mixture of of nitrogen and oxygen and the other trace gases. Okay, the individual molecules of gases are far apart, as opposed to say liquids. The liquids are much closer together, and solids even closer to. And so gases are going to, not for us because we're big people, but in terms of the gases themselves, the molecules are going to be fairly far apart. Well, this was a fairly short section, characteristics of gases, section 10.1, and so we are now gassy. We're very gassy in this chapter. So on to section 2, which talks about what pressure is.